welcome you back in geological knowledge. So as you know that we are dealing with some important chapters or important topics which are uh, important for the point of view of GSI mains. Okay. So in the succession of that discussion, today we will discuss a very important topic, that is the marine mineral resources. Okay. So what we will discuss, that where they occur, what are the marine mineral resources, and what are the occurrences uh, in our country, and what is their significance as well. Okay, so let's start our today's discussion. So firstly we will discuss some basics about the marine mineral resources. Okay, so what are these resources and where they are being deposited and where we mine from them. So basically oceans, they cover approximately 70% of the earth's surface, we all are aware with the fact, and they host a vast variety of geological processes which are very responsible for the formation as well as the concentration of mineral resources, and are ultimately they are the repository of many materials which are eroded or dissolved from the land surfaces. Okay, hence oceans contain vast quantity of material that presently serve as major resources for the humans. Today direct extraction of resources, if we talk about the direct extraction of resources, that is limited to salt, okay, magnesium, placer gold, tin, titanium, and the diamond, as well as the fresh water. Obviously fresh water is there, but if you talk about some precious metals, that is the gold, okay, and other material like tin, titanium, and diamond also. And the salt, we are aware with that is salt is deposited in the oceans. Okay, and the magnesium as well, placer gold as well, as we have discussed. So in the ancient times, the ocean deposits of sediments and the evaporites, they are now located on the land. They are very originally deposited under the marine conditions. Okay, so what is given here, that is in ancient times or in ancient oceans, the deposits of sediments and evaporites now located on land, previously they were originally deposited under the marine condition. Okay, so because of some other factors like sea level change or the eustatic sea level change, so that can be the prime factor for the migration or the uh, lowering of the deepening of the sea level. So that can regulate the migration of the material from the oceans to land. Okay, so these deposits are being exploited on a very large scale, and they are, and in preference to modern marine resources, but because of their easier accessibility and lower cost of terrestrial resources. Okay, these mounds of sea salt, they were mined from the deep buried beds deposited when the sea water evaporated in any ancient environment. So when they were formed, so these types of mounds of salt, suppose if we take an example of salt, okay, so if we talk about mounds, so as you see in the diagram, that is the mounds of salt. Okay, so these mounds of salt, sea salt, they were mined from the deeply buried beds which were deposited when the sea water evaporated in an ancient environment. So that gave rise to the formation of sea salt. And the beds were preserved by being covered and then uplifted in modern terrestrial settings where we get the salt. Okay, so mining accounts for most of the annual salt production, even though it also can be obtained by the evaporating ocean water. Now we will talk some very important and fundamental marine mineral resources. So the seabed of the Indian Ocean, that contains a variety of marine mineral resources and deposits ranging from beach sand and the gravels through the heavy minerals associated with the beach deposits to phosphorite and the ferromanganese nodules, the metal rich muds or the sulfide ores which are deposited, and the subsurface petroleum resources. Okay, so the basic and the fundamental or the important marine mineral resources related to India. So what they are, that is the beach sand in the coast of Kerala, Tamil Nadu, or in the Andhra coast or the Odisha coast. Okay, so on the beach sand or the gravel through the heavy placer mineral deposits which are associated with to phosphorite and ferromanganese nodules. So which are important marine mineral resources? So these are polymetallic nodules or the manganese nodules basically, the phosphorite, the sea floor massive sulfide deposits, SMS type deposits in short form we know as, cobalt rich ferromanganese crust or the placer minerals, and natural gas as well as the petroleum or mainly the gas hydrates. So there are so many marine mineral resources, but we will discuss only with the important one, which are very important from your exam perspective. We will discuss only with those types of resources. Okay. So let's start our discussion with polymetallic nodule, and this is two diagrams of polymetallic nodules. So what are polymetallic nodules? So these are basically the iron, magnesium, iron, magnesium, or sometimes copper oxide deposits. Okay, and basically they are potato shape and porous, black, earthy colored with size ranging from 2 to 10 centimeter in diameter. So you have to keep in mind the important properties, that is they are the iron, manganese, and copper oxides, and their shape is potato shaped, and they are porous, black earthy color, and the size range is important, that is from 2 to 10 centimeter in diameter. Okay, and if we talk about their occurrence, so they occur at nearly 2 to 5 kilometer depth in the deep oceans, and they take 1 million years to grow to 1 millimeter. This is very important, that 1 millimeter 1 millimeter to grow, they take 1 million years. So it's quite long time for their growth. Okay, and if we talk about the basic minerals present in the nodules. Okay, so todorokite and delta MnO2 are the two main minerals present in the nodules. Nodules rich in manganese have todorokite, and those rich in iron they have the delta MnO2. Okay, so this is the minerals which are basically present in the nodules. And if we talk about the formation of nodules, so basically we are dealing with the basics only. Okay, because in the exams there will not be asked question, it can be asked that write a short note on the polymetallic nodules, so you can write it down as we have discussed, but in detail you don't have to go. Okay, you have to go for the basic and the important factors about the nodules or any other resources in the sequence we will discuss. So only the important factors about them you have to know. Okay, and if we talk about the formation of the nodules, so there are basically three main processes for the formation: the hydrogenous process, the diagenetic process, and the mixed type. So in the hydrogenous process, whereby metals they are supplied from the water column, and these accrete on the suitable nuclei. So hydrogenous nodules they have been smooth surface texture. Their surface texture is smooth, and they are very rich in iron, cobalt, titanium, potash, okay, phosphorus, and other lead content. Okay, so hydrogenous process that produces some that is of smooth texture, surface texture, as well as the rich in iron, cobalt, titanium as we have discussed. And if we talk about the diagenetic process, so diagenetic process that supplies metals from the underlying sediment through the pore water by the remobilization. So diagenetic process that supplies the metal content from the underlying sediments through the pore water by remobilization. So diagenetic nodules, they are rough surface texture and they are rich in manganese, copper, nickel and the zinc content. As well as we have discussed about the hydrogenous process. So these were important in terms of iron, cobalt, titanium and zinc content. Okay. And mixed type means they may be combination of, sometimes they are in occur in the combination of hydrogenous as well as the diagenetic type. Okay. And next one is phosphorite. So what is phosphorite? So phosphorite is a non-detrital sedimentary rock which contains high amount of phosphorite bearing minerals. And if we talk about the, when we call the high amount of phosphate bearing minerals, so the most important phosphate mineral, that is apatite. Okay, and formula being Ca5PO4O3. Okay, calcium phosphate. So these, so apatite is very important. Okay, and the phosphorite is present at fluorapatite, typically in cryptocrystalline masses, and also as uh, hydroxyapatite. Okay, so phosphate that is present as fluorapatite and typically in cryptocrystalline masses, as well as the hydroxyapatite. Okay. Phosphorite deposits, they are often occur in the extensive layers which cumulatively cover tens of thousands square kilometers of the earth crust. And if we talk about the phosphorites, they can occur in dark brown to black beds ranging from centimeter size laminae to beds that are several meters in thickness. Okay, so they can be either in the form of lamellae or the form of the beds which are several meters thick. Okay, if we talk about very important occurrence of phosphorus deposit, that is the Jamarkhotra in Rajasthan. Okay, Jamarkhotra phosphorite deposit is very important. When we will discuss about the distribution of phosphorus deposits, we will discuss in detail that what are the country rocks in which this phosphorite deposit is being mined. Okay, I have told you here only for the knowledge perspective. In detail we will talk there. And if we talk about the formation, so the heaviest accumulation of these phosphorus occurs on the ocean floor. Okay, basically the heaviest or the most extensive accumulation, that is on the ocean floor. Phosphorus accumulation that occurs from the atmospheric precipitation, dust, as well as the glacial runoff, cosmic activity or the underground hydrothermal volcanic activity, and the deposition of the organic material. So if we talk about the phosphorus accumulation occurs from the following categories as written here: atmospheric precipitation, dust, glacial runoff, and the cosmic activity, underground hydrothermal activity, volcanic activity, and the deposits of organic materials. The primary inflow of the dissolved phosphorus is from continental weathering, brought out by rivers to the oceans. Okay, if we talk about the primary inflow of dissolved phosphorus, so that is from the continental weathering, that is brought out by the rivers to the ocean, and it's then processed by both the micro and the macroorganisms. Okay, primary inflow that is carried from the rivers, by the rivers in the oceans, and then they are processed by the both the micro and the uh, macro organisms. Okay, they are treated by micro as well as the macro organisms. And the diatomaceous plankton or the phytoplanktons or the zooplanktons, they process and dissolve the phosphorus water. Okay, phosphorus in the water. So that is the process. What are the organisms? They are the diatomaceous planktons or the phytoplankton or the zooplankton processes. They often dissolve the phosphorus in the water. Okay, and you will be knowing that the bones of some microfossils, they are made up of phosphate, some are made up of silica, some are made up of calcium. Okay, and some are also form of phosphorus. The bones and the teeth of certain fish, as we were dealing, the bones as well as the teeth of certain fish, they are absorb phosphorus and later deposited and buried in the ocean sediments. So the journey is very important, that the primary inflow, they get the material from the rivers, then that is deposited in the rivers, or sorry, via rivers, that comes to the oceans, and then they are attacked by the microorganisms or the micro as well as macroorganisms, especially the diatomaceous plankton or the phytoplanktons and the zooplanktons. So their bones and teeth of certain fishes, they absorb phosphorus and later they are deposited as well as buried in the form of ocean sediments. So the whole journey is very important. Okay. And next one is sea floor massive sulfide deposits, or better known as SMS type deposits. So many vent sites, they create SMS deposits, they containing ore grade and some precious metals of copper, zinc, cadmium, lead, iron, platinum, as well as silver and gold. Okay, so seafloor massive sulfide deposit is a broad topic. Here we are dealing with only the basics or some occurrence, so we cannot deal with the all the things about seafloor massive sulfide deposits. The range of the metals contents in SMS type deposits, that is just general idea. Okay, if we talk about Au or the gold, that is 0 to 20 gram per tons or the parts per million or ppm. Ag silver, that is 0 to 1200 gram per tons. Copper, that is 0 to 15 weight percent. Zinc 0 to 5 weight percent. Lead, that is 0 to 23 weight percent, and iron, that is 5 to 50 weight percent. So most important is that is the gold as well as silver. Okay, and the remaining ones, copper, lead, zinc, as well as the iron, they are in less amounts. Okay, and next one very important, that is the cobalt rich ferromanganese crust. Okay, so cobalt rich ferromanganese crust that exhibits similarities and differences to polymetallic manganese nodules. Like manganese nodules, the crust are slowly precipitated from the metals that are dissolved in the seawater. Okay, so like manganese nodules, the crust that is slowly precipitated from the metals which carries the dissolved material in the seawater. The metal and the metals are derived from a combination of sources comprising dissolution from the continental rocks as well as the transport into the ocean by rivers and discharge of metal rich hot spring in the deep ocean. So what happens, that is the metal, they are derived from a combination of the source comprising dissolution from the continental rocks and the transport into the ocean by rivers and discharge, that get discharge of rich metal rich hot spring in the deep ocean. Okay, and another very important deposit source, that is the natural gases as well as the petroleum. So marine pleasure minerals, they include ilmenite and associated with heavy mineral sands, tin, diamonds, as well as gold, and sand and gravel and phosphorites uh, form other important marine mineral resources. If we talk about natural gas and petroleum from shallow and deep sea reservoir, they contribute a significant part of the fossil fuel consumption into the in the world. Okay, And next one, another important one, that is the gas hydrates. So a gas hydrate is a crystalline solid in which a gas molecule that is surrounded by the cage of water molecules. So what are the gas hydrates? So these are the crystalline solid in which a gas molecule that is surrounded by a cage of water molecules. So these naturally occurring hydrates containing mostly methane adjust in a vast quantity in below the permafrost zone. Okay, so the occurrence of methane in gas hydrates, that is very important resource, but its mining is necessary. Its mining is little bit tough because it's occurring in higher quantity below the permafrost zone. So the mining is very costly. As written here, gas hydrates is a potential energy resource environmentally more acceptable compared to petroleum resource, and is also looked upon as the future energy resource. Okay, because it's less pollutant, and it is present in ocean sediments along the continental margin and is in the polar continental settings. Okay, so their occurrence is very broad in the oceanic sediments as well as along the continental margin and in the polar continental settings. So recent discovery of the one of the richest gas hydrates in the world in the KGM basin in the Andaman Sea of India, that has been recovered. Okay, so this was our discussion about the gas hydrates, and it's very important topic for you to understand that where the minerals are resources are being mined. Okay, and what are their properties, at what depth they are being mined. Okay, so this was all about the marine mineral resources. Thank you.